Welcome back again, Advanced Functions. This is Polynomial Equations and Inequalities chapter. In this lesson number 3, we are going to solve polynomial inequalities. Now, so for when we're solving inequalities, we need to use a chart sign method. So the reason why we use a sign chart is to figure out the sign of each factor by subbing in that number in the interval, and we are going to evaluate the function, whether it's greater than or less than that number. Okay, so let me show you how to use a sign chart. So question is solve this inequality. Okay, now first things first, if it's in a factor form, it's perfect because you already know what the zeros are going to be. So in this case, my x-intercepts is 2, -1, and -5. And what's the degree? So it looks like the degree of this inequality, this expression, it's 1 plus 1 plus 1. So it's degree of 3. Now the leading coefficient is positive, right? If you were to expand it, the leading coefficient, it's going to be 3x cubed. So we know the end behavior of this graph is going to be this way and this way. Okay, so let's make the sign chart. So we are going to align the numbers from small to big. So we have -5, -1, and 2. Okay, so this is my x-axis. And now let's plug in a number so we have pretty much a 3 interval. So what that means is that we have an interval from -5, -1, and from -1 to 2, and then 2 to infinity, right? And then -5 to the negative infinity. So let's start from left to right. So let's pick any number that is smaller than -5. So for example, we could choose, let's say, -6. So I'm going to plug in -6 into the expression, and all I care about is the sign. So in this case, if I were to plug in -6 into this expression, it's going to be, so 3 is positive, so -6 minus 2 is going to be negative, times -6 plus 1 is still going to give me negative, and then -6 plus 5 is going to give me negative. So let's see, negative times negative times negative is still negative. So therefore, the sign in between -infinity to -5 is going to be negative. Okay. Now, so let's plug in the next interval. So we're going to plug in a number that's in between -5 and -1. So for example, it could be -2. Okay, so I'm going to plug in -2 into this equation again. -2 minus 2 is going to be negative. -2 plus 1 is going to be negative. -2 plus 5 is going to be positive. So negative, negative, these two becomes positive. Positive times positive is going to give me positive answer. Okay, now, so we are going to plug in the next number that is in between -1 and 2. So I could plug in, for simplicity, let's plug in 0. Okay, so 0 minus 2 is negative. 0 plus 1 is positive, and 0 plus 5 is positive. So positive, positive times negative is going to give me negative. Okay, next, let's plug in a number that is greater than 2. So any number that's greater than 2. So that I could plug in, let's say, 3. So 3 minus 2 is positive. 3 plus 1 is positive. 3 plus 5 is positive. So positive times positive times positive is going to give me positive. Okay, so that we have just evaluated using interval chart. Now what we're going to do is figure out which interval is going to be greater than 10. Greater than 0, meaning that it's going to be positive above the x-axis. So this is positive, greater than 0, and this is also positive, greater than 0. So as you can see, the solution for this inequality is that x is in between, so it's greater than -5 or less than 1, or we could say x is greater than 2. So this is a set notation, and you could represent it using a interval notation. So in that case, it would be -5, 1, union, or 2, infinity. Okay, so one or the other is correct. Let's try letter B. So we're solving it, and as much as possible, if you could factor it, that would be the best because you can figure out the zeros right away. So I can simplify this further, which is a difference of square. So x squared is going to be x minus 2 and x plus 2 and x plus 1 and greater than 0. Okay, so it's perfectly factored. Let's identify the x-intercepts. So x-intercepts in this case is 0 for the first one, 2, -2, and -1. So what I'm going to do is I'm going to make the sign chart from small to big, -2, -1, 0, and 2. So this is a time where we are going to plug in a number that is smaller than -2. Okay, so let's see, I could plug in -3. So let's plug in -3 into this equation and tell me what your sign is going to be. So I can show you the first one. So -3 squared is going to give me positive, right? Don't forget the bracket. -3 minus 2 is negative. -3 plus 2 is going to be negative. -3 plus 1 is also going to be negative. So positive times negative is negative. And then negative times negative is going to be positive. And then positive times negative is going to give me negative. Next, so let's plug in a number that is in between -2 and -1. So in this case, it could be like -1.5. So let's see. I'm going to plug in -1.5 into the equation again and figure out what the sign is going to be. So -5 squared is going to be positive. -5 minus 2, negative. -5 plus 2 is positive. -5 plus 1 is negative. So when you multiply all the signs, what do you get? Negative becomes positive. So the sign in between -2 and -1 is going to be positive here. Now let's see. We're going to plug in a number that is in between -1 and 0. So it could be -0.5. So you try it on your own and see what the overall sign is going to be by plugging in -0.5. So -0.5 is going to be positive. -0.5 minus 2 is minus. -0.5 plus 2 is positive. And -0.5 plus 1 is going to give me positive. So overall, when you multiply, is going to give me negative. Okay, so the last two we have, let's plug in a number that is in between 0 and 2. So you could plug in 1. And when you plug in 1, you are going to get negative. And let's plug in a number that's greater than 2. So let's say, for example, 3. So I'm going to plug in 3 into x, and the interval, the sign is going to give me positive. Okay, so after you figured it all out, now is a final step of figuring out which interval is going to give me greater than 0, meaning it's going to be positive. If it's less than 0, that means you have to figure out interval that will give you negative sign. So in this case, positive and positive. So therefore, it looks like my interval is in between -2, -1, union 2, comma, infinity. Or you could use represent using a set notation. So -2x, -1, or it could be represented using v for set notation, and x is greater than 2. Okay, one or the other will be sufficient. Now, so there's another way to represent solving inequality. It's very similar to using a sign graph. So let's see. So graph the factor polynomial and then conclude about its sign. So we have x times x minus 2, x plus 3. Degree of this polynomial expression is going to be 3. The leading coefficient is going to be positive. So we know that the end behavior is going to be this way. So because it's by graphing method, label your x-intercepts from small to big. So it looks like x-intercept is 0, 1, and -2. So -2, 0, and 1. So I'm going to circle the zeros. Now let's plug in. So it's the same idea as the interval. What we're going to do, we're going to plug in a number that is smaller than -2. For example, it could be -3. So I'm going to plug in -3 into the equation. So -3 becomes negative. -3 minus 1 is negative. -3 plus 2 is going to give me negative. So negative times negative times negative is going to give me negative. So therefore, if it's negative, it's below the zeros, the x-intercept. Okay, so below. Now let's plug in a number that is in between -2 and 0. So for example, -1. Again, same thing. Let's plug in -1 into the x. And the overall the sign is going to give me positive. So if it's positive, that means it's going to be above the x-axis. So if I have to connect the zeros, it's going to be this way. And from 0 to 1, let's plug in 0.5. So plug in 0.5 into x and tell me what the overall sign is going to be. So the overall sign, 0.5 is positive, 0.5 minus 1 is negative, 0.5 plus 2 is going to be positive. So the overall sign is going to be negative, meaning it's going to be below the 0. So because it's polynomial, you have to make it a smooth curve, like that. And then anything after 1, so let's plug in 2. So plug in 2 into x again, it's the same method. And you will notice that the sign of that is going to give you positive, meaning above the x-axis. And it makes sense. It's going to be this way. Okay, so therefore, the final step after figuring out the interval sign is to figure out which interval is going to be greater than 0. Greater than 0 means above the x-axis. So it looks like this interval is above the x-axis, and from here to here is above. And because it's not including 0, so x belonging to in between -2 and 0, or it could be 1 to infinity. Okay, so that is how you find solving inequality by graphing method. Okay, let's continue further. So we are given, now we have like square and cubic this time. And so we have to collect the like terms. First, I would, because this is not factor form, we have +5. So if you don't have anything that's factor form and you can't put it that way, then all you need to do is expand and simplify and collect the like terms. So in this case, x plus 1 squared is going to be x squared plus 2x plus 1, okay, less than, and then we are going to expand for this one. It's going to be x minus 2. So I'm going to do the FOIL for x minus 2, x minus 2. So it's going to be x squared minus 4x plus 4 plus 5. Now I have to do distributive property again, keep going. So it's x squared plus 2x plus 1 less than or equal to, then it's going to be when you do the distributive property, you get x cubic minus 4x squared plus 4x minus 2x squared plus 8x minus 8 plus 5. Okay, so I'm going to collect the like terms and put everything to one side. So let's bring this to this side and make it to 0. So 0, and then so x cubic minus 7x squared plus 10x minus 4. This is the overall equation after you collect all the like terms. Now, so the last thing is you want to factor to figure out the zeros. So in this case, I'm going to use a factor theorem. So the 0 possibilities, it could be multiple of 4. It could be plus or minus 1, 2, or 4. So if I were to plug in 1 into this equation, is going to give me 0. Okay, so we know that 1 is going to be a factor. So let me do a synthetic division with 1. So 1, -7, 10, -4, 1. So bring this to down. So it's 1 times 1 is 1. You add them together, -6. It's -6. You multiply 4. 4 times 1 is 4. And it's 0. Okay, it's a perfect factor. So we know that it's going to be x squared minus 6x plus 4. Okay, and the other multiple is going to be x minus 1. Now let's factor this further, x squared minus 6x plus 4. Okay, so it seems like it's not factorable. So if it's not factorable, again, because it's quadratic, we are going to use a quadratic formula. So please do the quadratic formula on the side. So let me write down x is equal to negative b, so it's going to be 6 plus or minus, so b squared, which is 36, minus 1 times 4 times 2 is 16 over 2 times 1 is 2. Okay, so let's simplify further. 6 plus or minus 2, so I can find a perfect square, which is 20. 20 times 4 is 4 times 5. So I'm going to bring that to the other side, so it's 2 square root 5 over 2. And I can simplify further. It's going to be 3 plus or minus square root 5. Okay, so we found the zeros. So it looks like the zeros are going to be, let's write it here in red pen, in a graph. And so it's 1. We have, this could be 3 plus square root 5. This is 3 minus square root 5. And these are my zeros. Now I'm going to plug in a number that is smaller than 3 minus square root 5. It could be like negative 10. So we're going to plug in negative 10 into this formula. Okay, so you can plug it in here into this and tell me what the sign is. So you will notice that it's negative. So if it's negative, that means it's going to be going downward. And let's plug in a number that's in between 3 minus square root 5 and 1. So for example, I could plug in 1.5. So let's plug in 1.5 into the equation, and you will get positive overall sign. So that means it's going to be above. And let's plug in a number that's in between 1 and 3 plus square root 5. So I could plug in 2. So let's plug in 2 into the equation, and the overall sign is going to be negative. And let's plug in 10. It could be any number as long as it's greater than 3 plus square root 5. And the sign is going to be positive. Now, we're not 100% done yet. So the final step is to figure out which part is going to be greater than 0 above the x-axis. So it must be here, greater than 0, and here, this section. So therefore, the x is, and it's including. So I'm going to use a square bracket, 3 minus square root 5, comma 1, or it's going to be 3 plus square root 5, infinity. And for infinity, you have to use a round bracket. And that is your final answer. So one thing to keep in mind when you are solving inequality is that put it in a factor form as much as you can by expanding and making it equal to 0 and factor using a factor theorem or a trinomial factor or even using a quadratic formula. Okay. Now next, so we have a different type of question. This time we're given a rational expression. So when we're given a rational expression, we know right away if we are able to cancel numerator and denominator, there's a whole. So rule number 1, if you can cancel, so that means there is a whole. Okay, it's an open circle. And keep in mind, the denominator, you set it equal, cannot be equal to 0. That is going to be your vertical asymptote. Okay, so first I want to factor numerator and denominator as much as I can. So I have a common factor of x, 3x squared plus 5x minus 2. And the bottom, it's a difference of square. X minus 2, x plus 2 greater than 0. So it looks like I can do further trinomial factoring. So using decomposition method, So it's going to be 3x minus 1, x plus 2, and then x minus 2, x plus 2 greater than 0. Now, do you notice that I could cancel anything, numerator and denominator? Yes, I have x plus 2 and x plus 2. So we know that there is going to be a whole at x is equal to negative 2. And now we have to let the denominator equal to 0 and see what it can't be equal to. Okay, so this one, x minus 2 equals 0, x is equal to 2. So therefore, it looks like my vertical asymptote happens at x is equal to 2. So x cannot be 2 because that is my location of the asymptote. So let's write the simplified version. So it's going to be x, 3x minus 1, x minus 2 is greater than 0. Okay. So then you are going to find the x-intercept. X-intercept is 0, 1/3, and 2. Again, let's figure out the zeros from small to big. 0, 1/3, and 2. So let's plug in a number that is smaller than 0. So you can plug in, let's say, negative 1, and you can plug in here 0.1, you can plug in 1.5, and you can plug in anything greater than 3. So I'm going to plug in all the following numbers into my simplified rational expression. Now let's plug in negative 1 into the equation, and you will get the overall sign is going to be negative. Plug in 0.1 into the equation again. The overall sign is going to be positive. Plug in 1.5 into the equation. The overall sign is negative. And plug in 3 into the equation. The overall sign is going to be positive. Okay, so now, which interval is going to be greater than 0? So that means this one and this one. So therefore, x can be in between 0 and 1/3 or greater than 2.